introduce, what is that, Farmer? Farmer, yes. Farmer with an O, thank you.
Thank you very much. Okay, so I guess we'll get this thing started, seeing as how it's about a minute after 5. I hope more people would show up, but you know, it is 5 o'clock and it's sun's over the yard arm somewhere. There you go. So, this talk is hacking smart meters. Is it a gateway drug? The short answer to this question I'm going to tell you right now is yes, it is a gateway drug. The question is, a gateway to what? But before we get into the talk itself, we have to get through some housekeeping. Unfortunately, I had originally planned on doing a far more technical talk at the beginning of this, and then I started running some of my ideas past my boss. And then my boss started running some of my ideas past our lawyers. Now, out of an immense, deep, abiding respect and abject fear of my company lawyers and their NDA, which reads like the Book of Revelations, I had to tone this down. I apologize for that. If you wanted to come away from this with pictures of meters and how to hack them, can't help yet. Not yet. See me afterwards, though. So, some of the housekeeping stuff. The contents of this talk are in no way to be construed as an endorsement or incitement for illegal activities. If you do something bad with the information I give you, it's your problem. The views expressed here are my own, not necessarily those of my employer, the organizers of this conference, my wife in the front row, or the Bavarian Illuminati who want to use the smart meters to control your thoughts. So, my name is Robert Former. I am the head of security research for Itron. My job, I have the coolest job in the world. I break stuff. And I hire other people to break stuff. So it's kind of cool. My previous experience includes working as a consultant. The way I got into the security power industry is I worked as a consultant for a major utility out in California who wanted to put in smart meters. And they said, perhaps we should take a look at this and see what kind of security is involved. So they had my company bring me in, and I spent 6 months looking at it. And I turned around and said, the answer to that question would be none. The security for the system is very bad. And then I walked away and did my consultant thing and went on to another job. One thing and another, without going into too many details, they came back and hired me. It seems that when you make a public criticism of the cut of the emperor's new clothes, there's a good chance the guy is going to come and recruit you to be his new tailor. You have to be careful with that. So, why would somebody who works for a meter manufacturer do a talk on meter security and how to hack a meter? Seems a little counterintuitive, doesn't it? One of the things that is a problem in the power industry, particularly in power distribution, are antiquated attitudes. Security is simply, we don't tell people things. We're going to be like the government. We're going to have lots of secrets. And we all know that keeping the same password on every meter a secret works every time, right? Wrong. So this talk is as much an education for my executives as it is for you. There's value in this kind of research, and it's hard sometimes to quantify how much value really comes from breaking things, from, say, just random person in here picks up a meter off eBay or wherever, I didn't tell you where to get one, by the way, and breaks into it and says, ooh, I found this wicked flaw. How do you quantify that value? And part of how I have to do that is by demonstrating how it can be done. At some point somebody will do it, and hopefully responsible disclosure will come into play and we'll be told first. So, kind of rolling the dice. The other thing is, I'm one guy, and my job is to take these meters, take them apart, find out how you can break them. But I only have one perspective, and it's pretty limited, and frankly, as far as being a hacker goes, or being a penetration tester, I may be one step above a script kiddie, I'll be honest, okay? I do not have mad hacksaw skills. But what I have is an ability to pay people with mad hacksaw skills, like this guy here, lots and lots of money. They like that. And as I said before, the perspective. Because a good example I like to trot out is Windows XP. Unpatch. Can anybody here think of a more security hole-filled piece of software than XP.
Windows 2000.
Nope, I think there are more vulnerabilities in XP, SP0. The thing is, how did Microsoft fix that? The guy who's actually my boss is one of the people who drove the security initiative at Microsoft when it took forever for Vista to come out. And Microsoft learned that all of these people who were hacking their stuff and trying to tell them about it, that maybe they should start listening to them. So they started a program where they listen to independent security researchers and take the results and incorporate them into the next month's rollout of, hellishly large patches. This is a perception that needs to be changed in my industry as well. So that's a lot of why I'm doing this. So let's get a little background. The original meters, how many people here still have a meter on the side of their house that has a little spinny aluminum disc and dials on it? Okay? That is the ever popular and long-lived electromechanical meter. This thing is a thing of beauty and wonder. It will last 40 years on the side of your house, but it's not real smart. So over the last couple of decades, digital capabilities have been added. Digital meters, solid-state meters, they're more accurate, they're more reliable, and once you add things like AMR, which means automated meter reading, you don't actually have to send bodies out into the field to read them. You can have somebody driving around a car, and it will pull the meters as they drive, and eventually the bubble-up systems came about, but it was always one-way communication. Now, the thing that's interesting about smart meters today, and the reason you should be interested in smart meters today, is because they contain a shut-off switch. And this is the thing that has a lot of people up in arms. Oh my gosh, what happens if the People's Republic of China or some patriotic Chinese group who is not necessarily associated with the Revolutionary Army decide to hack the meters and can turn off all the disconnect switches in the LA area? Obviously, this is a cause for some concern. So that's what AMI brings to the table. Now, why would you bother hacking a smart meter? What would be the value in doing so? Number one, the one that everybody wants to know, how can I get my power cheaper? How can I get free power from a meter? That's economics is always a big driver. We'll explain later why that doesn't work. Tooling your neighbor. This is one that I came up with. As I talk to people, they go, yeah, you know that guy who's got the German Shepherd that keeps fertilizing your lawn? And the 17-year-old kid that has an 8,000 watt stereo system that is dedicated entirely to subwoofer? If you really want to get back at that guy, jack his electric bill up to about $8,000. My personal favorite is for fun. These things are cool. They're new. It's a little computer on the side of your house. Why not get into it? Another one, and this is where things get a little touchy, is to make a political point. Because it doesn't matter who's in power or who signs the bill to spend stimulus money, somebody isn't going to like it. They're going to like it just because they don't like the other guy. So let's hack meters so we can make the president look bad. I know, it sounds like a bit of a stretch, but you'd be surprised how many people actually think that way. And the reason that we're going to pursue here, to get to the other side of the meter, that's where things get interesting. Now, before we go any further, my boss made me add this slide. Reasons not to hack your smart meter. Well, let's start with stealing electricity is illegal. Duh. Okay? I'm not going to tell you to go commit a felony. If you wind up in jail, it's not my fault. You're responsible for your own actions. This is on tape. Now my lawyers can see it. This is also not a piece of personal property. This isn't like rooting your phone or putting Android on your Nook color. This piece of equipment legally belongs to the utility. So the minute you open it up, you are in a world of hurt because you've just entered computer hacking territory. And from a legal perspective, it's getting more and more unpleasant. 240 volts AC. How many people here have ever touched 240 volts AC? Okay, so how smart were you after that happened? 240 volts AC, which runs around inside this meter all over the place, will kill you. If you're...
Very strange feelings when you're...
That's item number 4.
Rubber fuse.
One hand for yourself, one hand for the meter?
Don't use a Mac.
Yeah, don't use a Mac. It won't be a Mac when you're done. It'll be an Acer. The problem is the meters float ground. If you give a meter a path to ground, it's going to follow it all the way through your fluke. It's going to follow it through your logic probe. I'm proof positive of that, by the way. And it will turn your Mac into an Acer. But if you hook it up right, it's also a great way to cook hot dogs and prawns. So, what's on the other side? What can we get to? Other meters, field routers. Field routers are cool. We'll talk about those in a minute. Distribution automation. This is becoming more and more of a buzzword. Distribution automation is the ability of the electrical distribution network that your utility owns to react to demand. So you turn on your air conditioner talks to your meter then talks to the substation, and the substation says, aha, I have another 20 amps of demand on this particular leg. If you can screw with that, you can make life very interesting. Home Area Network, or HAN. This is where the meter starts talking to your house, to your appliances, to your HVAC system, and you can get up to untold types of trouble using that. The NAN is the Neighborhood Area Network. That is the pathway to other meters and to the rest of the system. System controls, it's part of distribution automation, but there are also system controls that exist on the other side at the substations that do things like change where your power is fed from. Now, if you can say, if a substation is being fed by two different high tension lines, and you can drop one of them off, you'll put too much load on the other one. It'll drop off. You know what happens? San Diego last week. The entire southwest corner of California went dark because somebody overloaded one transmission line. And no, it wasn't because of smart meters. And you can get to the rest of the utility network, and that's where the money is, of course. That's where your billing occurs, that's where your bill gets paid, that's where all this data accumulates, and there are a lot of fun things to play with there. So, how do I get there? Without opening the meter. Now this is an important distinction. One of the cool things about smart meters is they have a lot of RF in them, which means that you can theoretically do things to and through the meter without actually touching it. You can do it without actually having to see the meter. You can do it to your neighbor's meter. Because we all know what happens when you defecate in your own food dish, right? You don't play with your own meter. Buy them off eBay. And the way to do that, there are a number of different interfaces that don't require you to take the lid off. And the most important one I like to think is the NAN network, because this is a relatively high power, relatively low speed, self-organizing, generally frequency hopping spread spectrum network, which just kind of makes it fun to screw with to begin with. So that's a path in there. Everything that meter speaks over that particular connection. The optical interface. On the newer meters, I know a lot of you don't have them yet, but on newer meters, they have this thing that looks like a circle with a couple of eyes and a smile on the bottom. That is the ANSI Type 2 optical probe interface. You can do anything you want to a meter over that interface, up to and including operate the disconnect switch and load new software onto it. Fortunately, any meter manufacturer who's worth their salt has protected this thing with a variety of different mechanisms that I'm not allowed to disclose at this time because it would cost me my job. And nobody else will hire me anyhow. The Zigbee interfaces are 802.15.4. How many people have heard of Zigbee? Okay? Zigbee is supposed to be the industrial answer to Bluetooth that has actual, factual, real types of security that's supposed to be built into it. AES, granted it's in counter mode, things of that nature. But there are ways that you can play around in Zigbee and get around those particular security controls. 802.15.4 is a different flavor of the same thing. It generally happens on 2.4 gigahertz, so it's ISM stuff. And you can buy Zigbee snippers for about $150 online. And now the last one, I'm separating the HAN interface out. Even though the HAN interface typically speaks over Zigbee or 802.15.4, or I've seen some proposals where it actually uses 802.11, which I think is a very bad idea, but that's not my problem. With the HAN interfaces, you can talk to things inside people's houses. You can turn the refrigerator off. You can tell their HVAC system to crank the heat up to 110 degrees in the house. A lot of fun to be had there, depending on your definition of fun, and how much you hate your neighbor. Now what about if we go under the cover? This is where things get really fun. Because once you go under that polycarbonate cover, you're going to find a lot of components that are easy to track down, and theoretically, you can extract information from, like firmware. So you're going to look for things like discrete or external memory, JTAG interface. Anybody here know what a JTAG interface other than Matt? Okay, JTAG interfaces are a lot of fun, right? You can take control of the system. It's a debugging interface. It basically allows you to control the meter absolutely. There's also, inside every meter I've ever seen, a serial bus. And that serial bus is used to communicate with whatever method the manufacturer is using to haul data back, whether it's over the 900 megahertz network, neighborhood area network. Some of them, on more remote applications, actually have cellular modems built into them. So there has to be a common way to talk to that communications module so that that part can be swapped out. It's usually a serial interface. RS-422, RS-232. You need to learn the difference between them. And the last item I like to point out is the ability to hijack that communications port, because if you can separate it from the meter, you can pretend to be the meter behind it, and you can become a meter on the network. And you can spoof your own meter, you can spoof somebody else's meter. The possibilities are endless. So what do you look for when you're inside the meter? Every meter has a processor. Smart meters are smart because they have an MCU in them. None of them have anything particularly powerful. You're not going to find Itanium processors in here. You're not even going to find anything that's Pentium class. What you are going to find are microcontrollers. You're going to find the stuff that runs your iPhone or runs various, like your Linksys router is another good example. So ARM7s, MSP430s from TI, 8051 derivatives. These are all very common processors. And because they're common processors, that means that you can get development environments for them. Most of them are freeware. Eclipse is a good example. Beyond that, you look for the RF chipsets, because nobody really manufactures their own RF chipset for these meters. None of these meter manufacturers do. They buy them off the shelf. And they're very common processors. Many of them have MCUs built into them. So particularly the GrrCON series, that's just an 8051 with a radio hung on the side. Look for your memory types, because that's going to tell you how to attack it. Whether it's just standard SRAM, I've seen that in meters. More likely you're going to find SPI interface serial, flash, and EEPROMs. And without, again, going into too much detail, for the most part, the data that's inside those things is not encrypted. Card edge headers, this is a classic. Most of us have seen an ISA card, or the kind of thing you plug into those old big boxes, desktop PCs. Card edge connectors on an embedded system indicate a diagnostic interface, which means that it typically holds a JTAG and has direct access to memory. Pin headers will do the same thing for you. They very often won't have the pins in them, but if you look for rows, 2 rows of solder pads that are like 2x10, 2x14, those are usually straight up JTAG interfaces, and all you really need to do is solder a header onto it and plug in. And test points. Test points are a classic place for fun. You have no idea what they're going to do, but if you learn how to follow the traces, you'll find that they go to things like the SPI interface. There's some additional attack points other than the meter to get at the meter and get into the system. Every system I've seen, if they don't use a direct backhaul system of cellular or something similar to that, they have what's called a field router. And what that does is it takes all those 900 megahertz connections, organizes them into a mesh, and then backhauls all that data back to the head end, which is where all the magic happens. Now, what makes a field router interesting is you can affect literally 1,000 meters at a pop with one of these. So if you could attack a field router and take control of it and learn the protocol that runs over that RF LAN, you could, in theory, operate the disconnect switch on 1,000 homes at once. And you have no idea the chaos that that'll cause, particularly if you do it on a really hot day or a really cold day. It's kind of the brass ring, actually. One that I came up with recently that hasn't seen as much popularity because it's fairly complex is the ability to get between a field laptop, which I list up above there, and the optical probe. Now, a field laptop is what the utility uses when they can't talk to a meter over the radio. You know, the meter's gone south, the software's corrupted, somebody like you has messed with it. They got to be able to go out, reprogram the thing, reload the firmware. You do that with a field laptop. I can't imagine any ways you'd get your hands on a field laptop that don't involve doing something illegal, so you're going to have to use your imagination for that part. But if you should happen to get your hands on one, they're usually Windows. They're usually not patched very well. They're usually XP, SP1. So use your imagination from there. The data that's carried on them, you'll find encryption keys, you'll find firmware, you'll find alternate firmware, old firmware, new firmware, passwords. A lot of times you'll find the field text pornography. That's kind of fun. Using that field laptop, a lot of times, if you're like me, not as smart as somebody like Matt, you're not going to be able to extract those keys off the laptop. But what you do is you get between the laptop and the optical probe. The optical probe ultimately is just a serial interface. So you get in between there and you can catch those keys flying across it. You can catch those passwords flying across it. It's running at 38.4.8N1 usually. Now, one that I find interesting that a lot of the people who have been publishing results on this haven't been going after is what's called the metrology section. The metrology section is what actually measures your electricity usage. And it's basically a set of coils going around another set of coils, and it measures the current over time. And then it encodes that, and it ships it up to the register board. It's always, always, always a separate piece of the meter. So if you can get inside the metrology section, if you've got the stones to go screwing around with 220, you can modify that measurement system, and then without making any modifications to the data side of it, which will frankly be detected by the utility, you can affect how your electricity is measured. This goes back to some of the older methods of stealing electricity, like using jumper cables to go around the meter. We actually see that still. Now, the thing about smart meters, they have to have a way to talk back to the head end, and they have to have a common way to do it. Because most states require utilities that aren't like small municipals, they have to have two separate suppliers for meters and other equipment. What that means is those meters need to be able to talk to each other in a common way, and they need to be able to talk to the head end in a common way. So there have to be common protocols. Now the thing about the smart meter industry is there are about 6 companies that make up 90+% of the manufacturing capability. And we like to think that we're like Cisco. We make up our own rules. And then we force those rules down everybody else's throats, and then we go to the government and turn them into standards. So you want to know who the main players are? Well, that's going to be Elster, Census, Landis & Gear, our old friend General Electric, Silver Springs Networks, and my personal favorite, Itron. My personal favorite because they send me checks. What they turn their ideas into become RFCs, ANSI specifications, IEC specifications if you want to be international with it, and ISO specifications. You can use these publicly published documents to learn everything you need to know about the protocol that's running between the meter and the collection engine. And it's interesting reading if you're an insomniac. Good way to go to sleep. Look at layers 1 through 4 because it's going to be different from anything you've ever dealt with before. Is anybody here in the power industry? Oh boy, I've got people in the power industry here. I'm going to hear about this later, aren't I? It's all different, isn't it? It's all radio. You're not dealing with Ethernet headers anymore. You're not even dealing with IP for the most part. Because meters, traditionally, even smart meters, haven't been that smart, sticking an IP stack in one takes up more than 50% of the available processing power and storage. So it's been avoided. Now, as things moved along, as things like iPhones have come along and more MCUs are being used, the prices drop, so there's more power in the meters. So what's going to be happening over the next few years is you're going to see IP directly to the meter. Now, IP directly to the meter is a boon for the utility, because whereas today you have to, the meter shop people have to learn how to do these things, the enterprise people, they don't know anything about these protocols. This is all a big mystery. You're talking about 5.5 million endpoints in a single installation. How many people here have ever managed that many single points? Heck, even the utilities haven't done that before. So the enterprise people are freaked out by the sheer scale of it and the exposure. Your attack surface on this thing is enormous. I put together a proposal because of the sheer scale and density of sensors that you have in place, where you could use some of the RF portions of this to detect nuclear detonations on the other side of the planet and theoretically be able to pinpoint them down to 7 centimeters as a starting point. That's how big this stuff is. It's like a giant array telescope. So you have to be able to manage it in a way that you can buy in the market easily. And what's on the market? Enterprise people. Most of us security people are enterprise people. And what do we understand? We know IP. If you can do an IP table to make a firewall, it's going to happen a lot faster than trying to figure out how to do that with C1222. Now, there have been a lot of people playing around with this stuff. And there's a great deal of prior research that you can leverage. You know, you can do the lone wolf thing and you can show everybody how incredibly smart you are and do this all yourself, and more power to you. Or you can learn to look up names like Travis Goodspeed, Atlas of Doom, or Cutaway, or even Slugs on Toast. And they've done a bunch of research, and some of it's actually been published. Most of it has to be kept private because of NDAs, but things leak. Look for it. These are the people who dig into it. They publish, they do con talks, they do presentations, and they're generally part of the local GrrCON group. So check with your local GrrCON group. I know not everybody here is from the Grand Rapids and West Michigan area. So while we're a little desolate when it comes to organized security stuff in this area, over in Detroit, there's a good chance you're going to find somebody who knows a few things about this, or can at least give you some advice on how to attack it.
GrrSec.
The what? Oh, GrrSec. MISec. Representing over here. Hackerspaces. I haven't seen too much happening with hackerspaces here in the Midwest, but it's really, really active out on the West Coast and the East Coast. There's a lot of activity there. There's a lot of knowledge there, and everybody loves to share and play together on this stuff. It's like a big, warm, fuzzy party.
We just opened in Detroit.
I'm sorry?
3 hackerspaces in Detroit.
3 hackerspaces in Detroit. How warm and fuzzy are those parties? Or are they more like under the Ambassador Bridge rave? Everybody just gets high and dances. Ah, yes. The last resource I like to point out, and this has become more prevalent of late, are universities and national labs. A lot of universities like Carnegie Mellon, University of Illinois Urbana-Champaign, I think I'm saying that correctly, national labs like Idaho National Labs, Sandia National Labs, these are organizations that are conducting research into smart meters and smart grid in a general sense. They're not really going to have much that you can use to specifically attack the brand name meter that's on the side of your house, but they're publicly funded. You know what that means? They have to publish, and you have to be able to get your hands on it. So that puts a lot more information out there. You know, remember I was talking about how meter companies and utilities used to like to keep things just secret? See how well that's working out now? It's actually leaking out into the world. Some of the tools that you will find useful. Has anybody here ever played with IDA Pro? You used it to disassemble ARM before?
It sucks.
And then there are people who actually just kind of do it by hand in their sleep. I've seen him half asleep disassembling ARM code. For us mere mortals, things like IDA Pro, Hexrays, which is a decompiler. There are certain tools that are available on the Backtrack distro that are free. The Samurai distro, theoretically speaking, it was supposed to be released at DEF CON, but there were some hitches in getting some of the the package is pulled together correctly, but the Samurai Group is putting together smart grid hacking distribution. Now these are the guys who did the web testing framework at WTF. I'm going to be very interested to see what they come up with on smart grid. And the other tool that you need to be familiar with if you're going to do things with software, you have to know how to use GCC. And I say GCC specifically because it's free and because it's multi-platform. A majority of the programmers that I know, they know C like the back of their hand. C+, C sharp, you name it. But they have no idea how to adjust it for an MCU, like an ARM7, or an ARM9, or a Cortex. So you need to become familiar with the tools that are used to compile this software so that you can do an effective job of decompiling it, pulling it apart, changing it, recompiling it, shoving it back in a meter, and then driving a worm across the entire state. Oh, look, my remote actually works over here. Cool. The hardware tools part, this is my personal favorite on this part of it because I'm not really a software guy, but I love to solder stuff up and tear it apart. And I've actually brought with me today some of the tools that I use to do hardware hacking, and you're welcome to connect with me afterwards, and I'll show off some of my toys. Well, we'll show and tell. Soldering kit, desoldering kit, that's obvious. Cheap logic analyzers. Now, my boss lets me buy a lot of toys, but he doesn't let me buy $5,000 HP logic analyzers and just ship them around the country. Fortunately, there are companies like Soleil and Postscope that are manufacturing these things that are USB-based. And you just plug them in inside, get a nice little display. They'll do huge amounts of capture. You can do a huge amount of analysis. The Soleil in particular, I like, because it will also do protocol decoding. So if you plug this thing onto an SPI bus and watch it spew a bunch of memory as the meter boots, you can capture all of the firmware as it traverses the SPI interface and decode it using Soleil.
But it's really hot and well on Linux.
Yes. Postscope, they're kind of an up-and-comer. This guy, somewhere in the northern reaches of the former Soviet Union, as near as I can tell. I was a little iffy on buying from him just because I didn't know what was going to happen with my credit card. And then I decided I didn't care because it's the company credit card. He makes a cool mixed signal oscilloscope that's USB based. It's high frequency, it's high accuracy. It is a piece of beauty and wonder. But he pitched it initially as also having a wicked 16-line logic analyzer built into it, along with an 8-line logic driver, which would allow you to jump on a bus and drive it at the correct voltage levels and speeds.
Mine came from Romania.
Yours came from Romania. Okay then. Edis Radio. There's a project called the, I always mispronounce this, GNU. The GNU Radio Project. It's an open source software-defined radio. Now you'll notice that smart meters do a lot of things over RF. It's actually kind of what has the tinfoil hat crowd worked up because apparently it's making their auras turn pink. And it's giving them headaches and they can hear the Illuminati. We didn't want them to hear us. The Edis radio can basically work everywhere from DC to, I think, 6 gigahertz if you put the right front end on it. So there are some boards that are available for it. You have to put a front end on it. But there's some boards that are available for a very reasonable amount of money that will allow you to put a front end on and basically simulate a meter, read a meter, and everything else happens in software. So it doesn't matter if it's spread spectrum or if it's just, if it's frequency hopping spread spectrum or direct sequence, it doesn't matter. You can emulate it and you can decode it. And you can also simulate it. Spectrum analyzers. Now this is usually a high dollar item, but the guys over at MetaGeek came up with this cool little dongle. It costs about $200, and it's a 900 megahertz spectrum analyzer. It's not really quick, doesn't have particularly good bandwidth, but it will give you a good idea of what's happening on that stretch of bandwidth. They also make one for 2.4 and one for 5.8 gigahertz. Sorry. Cheap, easy to use. I can use it. I don't know if my mom could use it, but I can use it. Anybody here familiar with the GoodFET other than Matt? Okay, GoodFET is a piece of beauty and wonder. Travis Goodspeed decided that the Bus Pirate was a pretty cool piece of gear. It allows you to do all kinds of cool things on serial and JTAG. He took it one step further and basically built an open source board, which if you're really, really nice to him or do something very neighborly for the community, he'll just give you one of the bare boards. And it can be any kind of FET board you need it to be. It's kind of geared more toward MSP 430 and ARM implementation, but that's the majority of what we run into in this industry. It beats the heck out of spending $400 on a JPEG interface from SparkFun. BuzzPirate will do many of the same things. I actually use them both. They're both really good at certain things. Using them in conjunction is the most effective way. ANSI Optical Probe. Now, up until yesterday, I was under the impression, am I running over time? Oh, okay. Up until yesterday, I was under the impression that your only option for an ANSI Optical Probe was to go and pay the $400 that these silly things cost. And then my friend Cutaway informed me that there's an open source ANSI Probe project that actually has a complete project list up on Mouser. It's under $10 for all of the parts. I think that includes the housing. I'll be building one soon. ANSI Optical Probe is an essential tool if you're going to start tearing into meters. Now, we've gone through the how. We've gone a little bit into the why. What's going to keep you from succeeding? What are the barriers you're going to run into? Crypto, crypto, crypto. And not chumpy crypto anymore. In the beginning, in the Rev 1 meters, there was no crypto. Everything was sent plain text. The general idea was make a meter smart. As somebody said earlier, well, security wasn't in our build plan. It is now. Real crypto has been included in these, and for the most part, you're going to run into variants of AES. Sometimes somebody's not paying attention and they'll do counter mode, but for the most part, you're going to run into more like Galwak counter mode, which is a little more difficult to defeat. Custom chipsets. A good business decision, if you're making enough of these things, is to build it around an off-the-shelf chip, like an ARM A7. I'm sorry. Yes, an A7. Or an M3. Or an MSP. Now the cool thing about these chips is that their original intellectual property owners do this thing where they will sell that design and allow an ASIC manufacturer to put it on a chip for you. Along with things like an AES crypto engine, so you're doing crypto in hardware, you're not killing your software, throwing some flash, some operational RAM on the thing, and then covering the whole thing with a piece of plastic and putting obscure markings on it. Now you're going to take one look at that thing, and you're going to go, what the hell's that? You're going to look it up on Google, and Google's going to say, I don't know, custom chipsets. It does all the work. You can actually get most of a meter on one chip now. And doing the research on that chip is going to require a lot more than just being able to type things into Google. That's a real barrier I'm finding. Tamper detection has become a lot more sophisticated. Now, I can't go into the details of it once again because I like getting a paycheck. But the tamper detection isn't just a matter of having a little reed switch in there anymore. It's not just a ball in a cage that if you tilt the meter, it's going to set off an alarm. It's a lot more sophisticated than that now. Now, there are some things that happen that are not on the meter that will trip you up or will get you caught. Billing data mining. Now, the day after somebody put a meter on the side of a house, somebody else figured out how to get around that meter and get electricity without it being metered. As I said before, we've actually seen people use car jumper cables to go around the meter. Simple but effective, right? Kind of like shotgun. Well, the utilities discovered fairly early on that you can look for patterns in billing data. And you can say, oh, look, John Doe over here typically uses 1,100 kilowatts of energy in a month. But all of a sudden, 3 months ago, his use dropped by 50% exactly. And we'll look at the historical data, and they'll adjust it for seasonal things, and they'll go, this doesn't make any sense. And they will send a meter person out to look at your meter. And they will find your jumper cables, or the piece of aluminum foil that you put over it to try and get the signals to keep from leaking out. Funny thing about Faraday cages, you have to put them on all 6 sides. Nobody ever puts the Faraday cage on the back of the meter. So billing data mining is an old technique, it's very effective. You may get away with stealing electricity for a month or 2, they will catch you. Do not use my name when you're caught. The same theory can be applied to logging data. These meters talk a lot. They call home and tell home everything that happens. The temperature got a little weird, calls home. There was a change in the frequency of the feed, calls home. Somebody bumped it, calls home. This is a ton of data. We are talking about petabytes of data on an annual basis. Huge amount of stuff. Utilities mine this data to look for patterns, to see if you bump your meter like 5 times in a row in one day. Ooh, there might be something going on there. They look for that in their logging data. The other thing is, these meters don't just send regular logging data back, they send events back. So if there's something really significant that happens, it will send an alarm. And that alarm will go to a security event monitoring system, which has a correlation engine in it. And it'll do the same thing, it's just real-time data mining. And it will alert the SOC, and they will send the meter police out to see you. Nosy neighbors. That guy with the German Shepherd and the fertilizer. Yeah, he doesn't like you any more than you like him. He sees you out there screwing with his meter. There's a better than trivial chance that this person is going to call the utility and say, yeah, I saw him out there screwing with his meter, and he's putting tinfoil on it, and he put a magnet up on the side of it, and you might want to check out what he's doing. People do that. Look on the internet for ways to defeat smart meters. Oh man, it's a big business in California, and it is all crap. Protocol knowledge. Remember I was talking earlier? All these proprietary, no, they're not proprietary because they're standardized, but all these weird protocols have been developed to talk to the meters, whether it's over the ANSI Pro, dial-up modems, over the radio. Chances are, unless you are one of the 4 or 5 people in here who actually work for a utility, you've never run across ANSI C1218, C1219, or C1222. These are very specialized protocols. It's only been in the last 3 months that a module has been written to plug into Wireshark that will allow you to decode them. Thank you, Ed Barasett. And then the last one is me, hopefully. My job is to break these things in every way conceivable, to pay other people who are way, way, way smarter than I am, to break them in even more ways, so that we can fix them before we ship them. So, this is the part that the press always loves. Can you hack a meter? Absolutely. If you have enough time, and enough resources, and enough motivation. I don't care what security I put on a meter. I don't care what security I put on anything. You'll be able to, if you have enough resources, get through it. My job is to make it more expensive than it's worth, more trouble than it's worth, or just not much fun. So, I apologize for reading off the slides, and I also apologize for the fact that I don't have pretty pictures on my slides, but you notice mine are actually pretty readable. So, some closing thoughts. Smart meters are just now coming to Michigan. Detroit Edison is deploying them. I don't know where Consumers is with their program, but I understand they have one. A lot of the co-ops are deploying them now. I know that Great Lakes Energy has a couple of pilot installations. These things are coming. You're going to have to deal with them. They've been in California for a while. And California, well, California has a lot of very, very interesting people who are not necessarily thoroughly attached to this reality. So you're going to hear that smart meters are put in place by the government to spy on you. And you're going to see proof positive from reading time of use data and interval data that I can tell when you turn on your teapot. Wow. If I want to know when you turn your teapot on, I'll sit outside your house. Use a cheap piece of gear and just watch you. A lot of hype, a lot of misinformation. Meters are not going to give you cancer, okay? there is more, the amount of energy, RF energy, put out by a meter in a given day is an insignificant fraction compared to what your television puts out just as RFI, or your laptop. I love the fact that, yes? Oh, 5 minutes, thank you. It's not ionizing radiation. You know what? Do the research yourself. Be smart. Don't listen to idiots. And you'll find out what the truth is. My bottom line here, don't trust anyone who stands to make a buck on your trust. That includes me. Research everything I've told you here. Look it up and find out for yourselves. There's a character running around the West Coast right now who is harassing every installation. And he's talking about how horrible this RF emission is and how it's making people sick. And interestingly enough, he also runs a website that sells these little charms with a resistor in the middle of it that will protect you from all of those harmful electrical emissions. Yeah. So, a big point I'd like to make, and this is not marketing crap, okay? And part of the problem of having a manufacturer come up and do this sort of thing is you get a lot of marketing hype, right? The bottom line is, smart meters that are in place today have pretty good security in place. If you're going to undertake this, if you're going to hack a smart meter, you better be damn good. And if you're that damn good and you can actually hack a smart meter, smart utilities don't put SCADA on their smart meter networks now, do they, Matthew? No. The meters themselves are designed to be pretty darn secure, and that's because of lessons learned from the early pilot programs, and because people like me went through and said, wow, the security on these things are crap. The manufacturers listened, the utilities listened. Surprisingly, the utilities have these remarkable security teams in place, and some of the brightest people I've ever met. And they get a lot of traction. And when you start talking to boards and you say, yep, guess what? We can put these cool meters out there. They've got disconnect switches, and somebody can turn off every house in the place. And that will impact revenue. As soon as you impact revenue, you get the attention of the people who actually sign the checks, and they start demanding the security from the manufacturers like us, and it starts rolling out there. So there are people out there, I'm not going to mention names, but there are certain individuals who have made quite a splash getting on radio programs talking about how all smart meters are awful. And the Chinese are going to turn off your power, and the Russians are going to extort you and your utility company because all smart meters are awful. That's bullshit. And I know that because I have to test these fool things, and it's not a trivial thing to just break into them. So, and I hope my lawyers were watching that part. So, we're down to 2 minutes, I'm guessing. Questions? Anybody got, you can ask me anything you want. The worst thing I'm going to do is tell you, get an NDA. Go ahead. Yes?
To address the security issues for smart meters. What do you know about that, and what do you see happening throughout the United States?
I think that California has had to be a vanguard in many ways on smart meters because California is much more energy conscious than we are here in Michigan, thanks to Enron. The CPUC, pretty smart group of people, and they're very careful about putting rules in place because they have to understand the impact it has both on the utilities and on the consumers, and their job is to protect the consumers. I personally have not reviewed the new rules that are being proposed or that have been put in place by the CPUC, but just off the cuff, again, this is my opinion, not my employer, not my wife, not the Bavarian Illuminati. I think it's a good thing. And I think that you're going to see similar both privacy and security rules will be pushed out into other states as smart meters start rolling forward. Does that answer your question? Go ahead.
I'm from Chicago. In Illinois, we're having a big row about whether the utility companies can charge us, the consumers, to upgrade the energy grid. The main argument for it from the utilities is that this will save the customers money. smart meters save me?
The
If I
consumer-
have one tomorrow, does it save me energy?
If your utility implements interval billing or time of use billing, and you use the data that's available from your smart meter on your consumption, you install the appliances that have the interfaces, absolutely it will save you money. No question. The big question, of course, is how many people are actually going to do that? Okay? And that's a question that I can't answer. I'm a security guy, I'm not marketing. If I go stepping into that mire, I'm going to have to sell my soul and I won't be able to see myself in mirrors anymore. Did that answer your question?
Yeah.
There's a question back here.
What type of increase in attempts and/or results of deaths do you see?
I'm going to have to ask you to speak up. I'm sorry, I'm deaf as a post.
What types of increase in attempts, or do you foresee an increase in attempts and the resulting deaths?
So if I understood what you were saying correctly, have we seen an increase in attempts of people trying to hack these things now?
Since the release of the X10 sniffers information from NetCom.
The X10 sniffer information? X10 sniffer information has absolutely nothing to do with smart meters. Fortunately, the people who have been doing the development work on this were smart enough not to use X10 as part of the HAN, because X10 is just a horror show for security. I cannot discuss the attack profiles that we're seeing at the utilities that would breach both the trust of my employer and the trust of my employer's customers. And so I can't speak directly to whether we've seen an uptick, a downtick, or if it's flat. But I can tell you that X10 vulnerabilities have as much to do with smart meters as ice cream bars have to do with truck tires. They're both security things. They're both physical objects. That's the end of the relation. That help?
Yep.
Okay, I'm going to have to wrap it up. If any of you have any more questions, you're welcome to corner me afterwards. Again, worst I'm going to do is say, do you work for a utility? Do you have an NDA? Okay, let's talk. Thank you very much.
If you have one of the blue tickets from playing blackjack, the TV will be given away in 5 minutes, and it is not leaving in my vehicle. So if you have a ticket, we're going to keep drawing until